Instead of saying charges, from now on, I am going to say oxidation state, because oxidation state covers everything, molecules and ionic compounds. It doesn't matter which one you have. So from now on, I'm always going to say oxidation state. Make sure you balance the oxidation states. Okay? So I want you to go ahead and write oxidation states for everything there. Let's not divide out the P and the O. The PO4 is on your polyatomic ion sheet. You can write that based upon that. In the future, we'll probably pull that apart and we'll look at phosphorus and oxygen by itself. Okay? So that we get oxidation state of every element in the future. Okay? But for now, you can just write those in. Go ahead and determine which one's oxidized and which one is reduced based upon our discussion we had yesterday. Okay, so what is going to be oxidized, which one's going to be reduced? So which one do you want to get? Which one's reduced? Na, right? Plus 1 is 0. Reduced. It gets lower in value, right? Okay? So this one's reduced. Sodium is reduced. So I could write down here Na is reduced. Okay? Actually, Na plus 1 is reduced. Right? Because it's already over here, it's Na. So that's what's being reduced, so we can write reduced here. How many electrons does it gain? 1 each. Every one that goes from the left to the right gives up or gains 1 electron. Gain 1 electron for each one. Okay? Barium is oxidized, right? So the other one has to be oxidized. So Ba is oxidized. And how many electrons does it give up? 2. Loses 2 electrons. Okay? Let's go ahead and balance our reaction. So let's not look below to balance it. Let's just go ahead and balance it. So I have to have a 2 here, right? And then that makes 6 sodiums. And then I need a 2 here, right? Does that make sense? No, a 3. Duh. 3. Now is that balanced?
Yeah.
Okay. Now, how many bariums are going total after it's balanced? How many bariums are going left to right? 3, right? So each one loses 2, so that would be 3 times 2 is 6. How many sodiums are going? 6. Each one of them gain 1. 6. You don't have to show that. I like showing that just because we can see electrons are always got to be conserved in a balanced reaction. Okay? We'll have you do one more. We'll have you do, yes?
So it doesn't matter how many, like, sodium times 3?
So this is another one. Just go ahead and write the charges out. Determine what's oxidized and what's reduced. So again, if I was writing the individual ones on this one, what's oxidized and reduced, I would say Al plus 3 is reduced. And Na is oxidized on that one prior. So then you guys have to deal with iron. So on this one, if I wrote down what's reduced, that would be what? Oxygen is reduced. Okay? And then on this one, we say iron is oxidized. This is what causes metals to corrode that are made of iron, because that's just rusting right there. So anything that combines with oxygen forms rust, and it's brittle. We know it's brittle in that, so I can go ahead and fill this one down here. Oxidized, reduced. Okay. And then we're talking number of electrons that are lost or free. And then gained is 2. So everybody knows 3 and 2, right? So we should have 2 that go over. Alright? But that's not going to work because we got an odd number, so it's going to be balance 4, 3, 2. So we have 4 go over, that's 12 electrons. Okay, and then we got 6 oxygens, that would be 12 electrons as well. So that's what you'd have. Again, you don't have to show this, I just like showing it. So that's 2 electrons times 6, and that would be 12 electrons as well. So, okay? Alright. We're going to talk about a portion in the book that some of you have your book. If you do, great. If you don't, that's fine. All right? So, the first one, it says on there, pure elements are 0 charge. Okay, so we've been doing that, right? Anything by itself, we've been making it a 0 charge. Okay, so that's pretty easy. Number 2 is a very important part. When we have 2 nonmetals hooked together, then the one with the higher electronegativity is the negative charge. So I'm going to go ahead and write that down. When 2 nonmetals are combined, the higher electronegative element takes on the negative charge, the negative oxidation state. Okay, so most of the time we've got a metal and non-metal, and we give their oxidation numbers based upon what we've always had. And what's to balance out those oxidation states, we've been saying charges, to where they're an algebraic sum of 0. Alright? So what if we have nonmetals hooked together, like in CO2, carbon dioxide? You still have to assign oxidation numbers for that. So you look up carbon, and find its oxidation or its electronegativity. So what's the electronegativity of carbon? 2.26? Okay. Oxygen is 3.44, right? Everybody seeing we got those numbers? I don't want people to get lost. We've used those before. They're on the back side.
Carbon's 2.55.
Okay, 2.55 for carbon, and then oxygen's 3.44. So, oxygen takes on the negative charge. So it becomes a -2. We have two of them, which is a -4. What is carbon going to be? +4. Right? We still have to use our rules. They still have to balance out to 0. So carbon is a +4. Is +4 a possibility for carbon? Yes. So now these other numbers are going to come into focus. Okay? Some of these other numbers we work with are going to come in to play when we start doing this rule. Okay? Here's another one. PCl3. So look them up. Which one has a higher electronegativity? P or Cl? Cl. It takes on the -1 oxidation state. You got 3 of them. That's a -3. So phosphorus is a. Okay. Can phosphorus be a +3? Yes. So those other numbers are now should start making sense why they're there. Before we've already used the -3 for phosphorus. Okay, I'll give you one more example. NH3. Ammonia. NH3. The higher one is the front one on this one, right? Most of the time, the front one is going to be your positive. The second one is going to be your negative. How we say that happens 97% of the time. So it's most likely the second one that's listed, or the last one that's listed, is negative. But with ammonia, that's not the case. Okay, nitrogen is higher electronegativity than hydrogen, so it's a -3. So then what is hydrogen going to be? +1. Right? Hydrogen's a +1. Okay. Questions? Yes?
Okay, where are you getting the -3 from?
The periodic table.
Just like its charge?
Yep. And we're going to call it oxidation number. But yeah. Yep. So that doesn't ever change. Whatever the higher electronegativity would be what it would be if it's a ionic compound. Right? All right. A few more rules, and I'll put them down, but they're so easy to remember, but I'll still put them down. Fluorine's always a -1. Always a -1, because it has the highest electronegativity of anything. Okay? Oxygen is most of the time a -2. Exception is when it's with fluorine. I'll give you the exception. So if we have OF2, then fluorine always a -1. So oxygen's a +2 there. That's the only time that oxygen's a +2. Everything else, for the most part, is going to be a -2. Okay? All right. And then hydrogen is +1 with a nonmetal. And it's a -1 with a metal. Okay, so the example, we could have HCl. There it's a positive 1, because chlorine has a higher electronegativity. And CaH2, you can see it's behind. That's going to be a negative 1 there. So it's with the metal. It's a non-metal, it's a positive 1. When it's with a metal, it's a negative 1. Okay? And then the last little bit is with polyatomic ions. So you guys have your polyatomic ion chart. Go ahead and get that out. Now, if you deal with just polyatomic ion, it's going to equal the charge. So if you add up all your oxidation numbers, it's going to equal the charge of your polyatomic ion. Okay, give you an example. NO3, what's its charge? Negative 1. So if I add these up, these oxidation numbers, it's going to come up to be a minus 1. So which one has a higher electronegativity, oxygen or nitrogen? Oxygen. Well, it's always a minus 2, so that's another rule we can use. We have 3 of them. That's a minus 6. So what does nitrogen have to be to equal a minus 1? Nitrogen has to be a plus 5. Okay, so now it no longer has to be equal to 0. Dichromate, Cr2O7. Find it on your chart. What's its charge? Negative 2. So now it has to equal a minus 2. So oxygen again, I'm just going to put the total, minus 14. So 2 times what plus a minus 14 gives us a minus 2? 6. So chromium is going to be a plus 6. Alright? Yes?
Where do you find out what it's supposed to be equal to?
On your polyatomic ion sheet. Yep. These are all polyatomic ions. So you can look on there. Okay? So I've got 6 for you to do in your notes tomorrow. And then we'll come back and talk about those. We'll have a little lab tomorrow. We'll talk about oxidation states again. Then we'll do ACT prep. I couldn't get it working today. So I wasn't going to be. That's okay. So I'm going to go ahead and give you 6 to do. And you guys can put them in your notes. That is located on that list. So oxygen's pretty dang easy. At least you get, if you have a test and you have oxygen, you're going to get them right all the time. Okay? Exception is with fluorine. You're going to only have it so many times with fluorine. So feel pretty good about this over the last couple periods. I think we've done so much work with balancing charges, knowing how to work with oxidation numbers, that this is just an added little bit of information to help you out with that. Okay, so go ahead, write those down in your notes. We'll do those tomorrow.